In a region, the potential is represented by V of x, y, z is equal to 6x minus 8xy minus 8y plus 6yz, where V is in volts and xyz are in meters. The electric force experienced by a charge of 2 coulomb situated at the point x 1, 1, is what we need to find here. Okay, here the electric field is equal to minus, we know that is minus of dou V by dou x with the I plus dou V by dou y with the j term plus dou V by dou z with the k with respect to k. Then here V is equal to, they are given 6x minus 8xy minus 8y plus 6yz. Then electric field is equal to, that is if you are going to differentiate this one with the help of the x, then we'll get the value, that is 6 minus 8y into I plus of dv with respect to dy, that is with respect to y, we'll get the value, that is minus 8x minus 8 plus 6z with respect to j. Then plus, if I'm going to differentiate this one with the help of the z, then this becomes 6y times k. Then F is on the charge coulomb. Then we know that F is equal to, force is equal to Q into E, then which is nothing but 2 times of mod of electric field, which is at 1, 1, 1. Then we get the value F is equal to 2 times of electric field. 2 times of electric field is, that is 6 minus h I cap plus of minus 16 plus 6 j cap plus 6 y k cap. Then the magnitude, which is equal to minus 2 times of this value, that is 6 minus 8 is equal to, that is minus, that is equal to, we get the value 2 square plus 16 6 by 6 is equal to, that is 10 square plus this is 6 square. Then we get the value minus 2 times of 4 into 100, that is 436, that is equal to under root of 140. Then we can write this one as, if I am going to take this 4 into if I'm going to take the number 4, it becomes 2. If I'm going to take, that is 4 into 70 or 35. 4 into 35 is 140. That is a 2 into under root of 4 into 35. Then 4, if I'm going to take under the root, it becomes 2. 2 into 2, it becomes 4. 4 times 35 is the right answer. Then option D, force is equal to 4 root 35 Newton is the right answer.